Hello everyone, I'm Genevieve and I will be moderating our discussion today, and beside me are Samuel and Ryan, our experts. The topic we will be discussing today is on marine microplastics. Microplastics are defined as plastic particulates below the size of 5 millimeters. With such a small size, they often go undetected by the naked eye. There are two types of microplastics, classified by how they are produced and how they enter the marine environment. Primary microplastics are released into the marine environment directly. Examples of such include plastic fibers from clothing or small plastic byproducts from plastic manufacturing. These microplastics make their way into the ocean via wind, runoff, and wastewater release into streams, which in turn flow into the ocean. According to the Hsien, the highest global release of primary microplastics is from synthetic textiles, tires, and city dust. Secondary microplastics are produced when larger plastics, such as fishing nets and plastic waste, in the ocean are degraded. However, it is difficult to tell the origin of these microplastics. With that being said, what is the state of marine microplastic pollution in the world today?
Before we understand microplastics, we should understand the state of marine plastic pollution in general. So we currently produce 300 million tons of plastics per year, 8 million of which enters the ocean. And this is increasing by 4% annually. Regionally, Asia contributes 81% of this waste, with Philippines alone contributing 36%. This mostly comes from packaging waste.
So what does this mean for microplastics?
Extensiveness of secondary microplastics can be thought of as directly related to the general plastic pollution, since they are directly broken down from the larger plastics. Currently, we estimate this to be around 8 million tons per year. Primary microplastics is slightly different though. They are estimated to produce at a rate of 1.5 billion tons per year. Unlike secondary microplastics, all regions were found to contribute to this relatively equally and significantly too. India and South Asia contribute a bit more, but not that much. Surprisingly, only 2% is generated from marine activities, while 98% comes from land-based processes.
If total marine microplastics is about 10 million tons per year, and that's only like 0.03% of marine plastic pollution, why is microplastics such a significant issue, and what happens to these microplastics when they enter the oceans?
So in the oceans, in the environment, right, the fate of these microplastics actually depend on their buoyancy relative to seawater. So we have our positively buoyant microplastics. So these microplastics are lighter than seawater. So these microplastics would remain suspended in the seawater for a longer period of time. And this longer period of time that they are suspended in the seawater allows them to have a higher residence times, and this allows them to be able to easily enter the marine fluid. Then we have our negatively buoyant microplastics, and these microplastics are more heavy than seawater. So these microplastics will sink and then eventually get deposited on the seabed or your benthic environment, such as your reefs, your seagrass meadows, and then eventually they'll get buried.
So the fates of these microplastics seem to be attributable to the intrinsic buoyancy. Are there any environmental factors that also influence how they behave in the environment?
In fact, there are. Because they are so small, right, they are more vulnerable to be affected by these environmental influences. And we actually found out that different habitats can act as better sinks for these microplastics as compared to others. And this mainly comes in the form of your mangroves and your coral reefs. And why do you think so? Why do you think coral reefs and your mangroves actually act as better sinks for microplastics?
I think this is something to do with the greater structural complexity that these habitats have as opposed to the marine environment.
That's actually very true. The common denominator between these coral reefs and your mangroves is that they add this three-dimensional structure that protrudes into the water column. And these protrusions actually help slow down water movement within these regions, allowing them to act as local sinks for these microplastics. Unfortunately, this results in them being ideal dumping grounds for these microplastics.
Other than them being in the waters, trapped and buried in the environment, what are the issues that they could pose to marine life?
Due to their tiny nature and their widespread presence, these microplastics can actually be very easily internalized by marine organisms. And we actually know for a fact that certain marine organisms are actually more susceptible to internalizing these microplastics. So these organisms actually come in the form of your detritivores and your suspension feeders, mainly because of the way they feed that requires them to filter out their food from large amounts of sediments and water. However, at the moment we have not found out whether these internalized microplastics can actually harm the organisms themselves. And this is mainly due to the fact that these toxic effects mainly come from different aspects of the microplastics. So this can come in the form of the size, the nature of the microplastics, the chemical nature of the microplastics, the morphology, and the state of degradation in which they are ingested at a point of time. Yeah. So in simple sense, or in simple words, we actually just need more time for us to actually understand the interaction between your internalized microplastics and the consumer.
So since it's not fatal, then why is this still a problem?
Studies on goby larvae and forams has actually shown that in these individuals that have ingested microplastics actually exhibit like lower feeding efficiency, so meaning they eat lesser food. And this can be because these internalized microplastics can actually choke them or maybe occupy space in their gut, actually affecting their hunger in a sense. There's also a well-known fact that plastic contains a lot of your additives, like your phenol or your phthalates, and these have been known to be endocrine disruptors. So this just preludes to us about the potential physiological impacts that these microplastics, when ingested, could have on their consumers.
If microplastics are so damaging to wildlife, how do they affect humans?
We are most directly affected when we eat seafood. This might not be an immediate problem, but if someone consumes enough fish or shellfish that contains microplastics over a long period of time, microplastics can accumulate in our body until it reaches very high levels. This is also called bioaccumulation. Another phenomenon called biomagnification can occur too. This is where microplastic levels increase after each higher trophic level. Thus, the effects of microplastics are most magnified in us, which are apex predators. Some even smaller microplastics or nanoplastics could also potentially pass through our water filtration systems. Unfortunately, this means that our drinking water might have some of them as well.
If we ingest microplastics, would there be any consequences?
We should be most concerned about their toxic effects. Microplastics are chemically manufactured products after all. Also, because microplastics are insoluble and have very high surface area to volume ratio, they can easily absorb even more environmental contaminants, making them even more toxic. So they could disrupt our immune system, our nervous system, and even cause cancer.
Are there any real-life examples of microplastics affecting humans today?
To my knowledge, we have found microplastics in the placenta and stools of humans back in 2020. Whether these microplastics were found from the marine environment still remains unknown though. In general, empirical data of the microplastics threat to human is still at its infancy. However, all current models point towards it being a threat to human health.
What about the microplastic pollution in Singapore?
Singapore is definitely not spared from our microplastic pollution issue. In fact, a recent study last year actually showed that microplastics were actually found in very high densities in your mangroves and your reef crests. And this follows what we previously discussed about how these complex environments actually act as good sinks for these microplastics.
What other factors could affect microplastic loading?
I think one key issue that we have to always remember is about the connectivity of our oceans. So in Singapore, we experience two annual monsoon seasons, so northeastern monsoon season and your southwestern monsoon season. And it was actually found that during the southwestern monsoon season, Singapore actually experiences a higher amount of microplastic loading as compared to your northeastern monsoon seasons. And this can be because of your southwestern monsoon season actually bringing a lot of water from coastal seas that actually borders like countries like Indonesia towards Singapore. But on the other hand, for your northeastern monsoon winds, they actually bring water from your more open South China Sea down towards Singapore. So these environmental factors actually do play a role in dictating Singapore's microplastic environmental loading.
So far, we have mentioned the detrimental effects of microplastics. Hence, there have been various solutions that scientists are looking into, like cleanups and the possible banning of plastics and microplastics. What do you think of these solutions?
There have been new innovations in how we approach this. For example, the Ocean Cleanup has developed plastic collectors to remove floating plastics in the ocean. There has also been research into bacteria which can metabolize these microplastics too.
There are actually statistics that show that your microplastic collectors or your plastic collectors are not as efficient or functioning as well as we thought them to be. These plastic collectors can also pose a threat towards marine life. It is also very difficult as of the moment to separate your plastic particles from sediments because of their similarity in density or in size. Until we are able to find or develop a technology that can actually separate these two, I think that banning single-use plastics is the way to go to prevent the issue from getting worse. And there are a lot of success stories. So in 2015, the US actually conducted or enforced an act, the Micro-Free Waters Act, that actually banned the use of your cosmetic-based microplastics. In the EU in 2020, they also enforced a ban on the microplastics that are normally used in the very commonly used products. So this can come in from your detergents, your paints, and your polishes. Although it is a big challenge, it definitely does require the involvement of many people.
But what about secondary microplastics?
Well, then more general plastic bans should be in place. So countries like Australia, Philippines, and even most parts of the EU have already wiped out or removed majority of their single-use plastics. Although this is mainly targeting your larger plastic products, it's still a step in the right direction.
I think that would be the ideal situation, but that would require governments to be on board, which is harder than it seems. Plastics play an important role in many people's lives, and it's an incredibly large industry. For instance, in 2021 alone, the global plastic industry is valued at $593 billion US. Stopping plastic production altogether will definitely be at the cost of many livelihoods in the economy, so it will definitely be difficult to convince governments to put in place policies to ban plastic use.
So what I understand is that the cleaning of waters of microplastics is a tough task to do, and researchers are still finding ways to do so. I think we can all only hope that a solution is found soon, and that governments will start to recognize the impacts of microplastics and put in policies to tackle the problem. So with that, we have come to the end of our discussion. Thank you, Ryan and Samuel, for your opinions and expertise on the matter.